Recording in progress.
Yeah, comes on everything. Great. So last thing, we started with the work. Let's go ahead with the problem. So a pencil is used to draw a circle of radius r on a paper. F is the friction between pencil and the paper. So find work done by pencil on paper find work done by paper on pencil. Let's get this. So you took a pencil, you drew a circle of radius r, friction between the paper and the pencil is F. So answer will come in terms of F and R. Signs are important. So if I had to give you a diagram, think of like this. So this is your circle of radius r. So let's say this is my pencil. I'm using this red thing here. So you are making the pencil go this way. Pencil goes anti-clockwise. You can assume any direction, it won't matter. So you're making the pencil go in anti-clockwise and making a circle of radius r. Try. I'll give you a minute or two. It's a good one. Surya, you're fine. Yeah. Let's focus, everyone. Why people are missing? Let's see. Hmm. Look at the first one. Let's take the work done by pencil on paper. So when you do this, you ask yourself, what is your system? So here my system is the paper. So if you draw the FBD of the paper, so this is your paper. This is the circle you're drawing. So the pencil is going this way. So how will the friction be on the pencil? On the pencil, friction will be backward. On the paper, friction will be forward, right? So this is how the friction will be on the paper. Friction is anti-clockwise on paper because friction will be opposite to the pencil ka motion, but that is fine. Now ask yourself, what is the work done? Work done is force into displacement of point of application of force. So where are you applying force on the paper? This point, right? The points on the paper don't move. So think of like this: if you put your finger on your table and rub it, right? You're applying force on the table, but no point on the table moves. Points on the table do not move, or the points on the paper are at rest. So there is a force, but there is no displacement. Therefore, work done is zero. So work done by pencil on paper is zero. It doesn't do any work. Is that clear? The second one is interesting though. Look at this carefully. So here your FBD is the pencil. So when you take your pencil here, the tip of the pencil, the friction will be this way. ds is the displacement. The ds is the displacement of tip of the pencil. Work done is force into displacement of point of application of force. The friction is acting on the tip of the pencil. Displacement of tip of the pencil. And you will notice here F bar and ds bar are always opposite to each other. Meaning if you see the displacement will be like this, I'll do one thing, I'll take the friction in red. So friction will be like this, friction will be like this, friction will be like this. If you look at the displacement, displacement will be like this, displacement will be like this. So be careful here. Friction is not constant. The magnitude is constant, but the direction is changing. So the work done will be integral F bar dot ds bar. This is integral mod friction mod ds. Angle between them is 180 degrees. So we get integral F integral mod ds. Now this is important. We did discuss this in vectors once. Tell me one thing. If you're going in a circle and let's say you're going in a circle. Now, if this is your ds bar, so this is a small displacement along the arc. So this is where, most people goof up because you studied this in school, right? If displacement is zero, work done is zero. You're getting it? That statement is a blunder. That statement is valid under a certain condition. In this case, the displacement is zero, but work done is not zero. So let's go there. But tell me this thing. So if you take this, the displacement is a displacement in a circle. So if you take all these ds bars, what is integral ds bar and what is integral mod ds bar? What is the difference between them? What is integral ds bar and what is integral mod ds bar? First of all, ask yourself, integral means what? Summation, right? Ds bar means what? Summation of vectors. So now you tell me, if you add all these vectors here, 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 what do you get? You get displacement, isn't it? You get the total displacement, isn't it? The summation of all the vectors. This would be zero, right, in one revolution. So if you make one full revolution, you will get zero. But what is integral mod ds bar? This is the magnitude of each piece, isn't it? You're adding the length of each piece. So what will get that? This is distance. This is 2 pi r. Are you getting the difference, everyone? Integral ds bar is summation of vectors. When you add all the vectors, you will get displacement, isn't it? The final minus initial. Triangle of vectors. But if you add integral mod ds bar, you're adding all magnitudes of each vector. So what you're doing is actually adding all these arc lengths, you'll get a circle circumference. Is that clear? So in this case, mod ds bar is what? Minus f into 2 pi r. So let me tell you that what you studied in school. If the displacement is zero, work done is zero, what is that valid for then? But is this clear, everyone? Any doubts on this page, please ask me. Now, what is that one? See, suppose if force is constant, if F bar is constant, understand one thing here. Remember, friction is not constant here. F bar is changing in direction. Friction का magnitude is constant. Friction force is not constant. Now see, if F bar is constant, this is what happens. Work done is integral F bar dot ds bar. This becomes F bar comes out integral ds bar. Then it becomes F bar into displacement. Or you can simply say F bar dot S bar. So if F bar is constant, then work done is zero if displacement is zero. So if F bar is constant and if displacement is zero, then work done is zero. So what you studied in school was this. Displacement is zero, then work done is zero. But if F bar is not constant, right, and displacement is zero, work may or may not be zero. Is that making sense? So remember, this is not valid. If F is variable, this is not valid. Because if F is variable, it won't come out of the integral. Right? If F is variable and if displacement is zero, work need not be zero. So that is the statement you learned in school. If the work done, if the displacement is zero, work done is zero is wrong. That is valid only when the force is constant. Clear with this? So the reason why it doesn't work here is because friction is not constant. Friction ka direction is changing every instant. Any doubts on this? Everyone clear with this? And remember one more thing, there is no such thing, there is no concept like Newton's third law for work. If I do work on you, you must do work on me. That is not valid. Did you see here? You're doing zero work. Pencil on paper is zero, but paper and pencil is not zero. So that would be one more conceptual thing you can keep in mind. So I can just add it here. So work done by A on B need not be equal to work done by B on A. There's no compulsion like that. Sometimes maybe luckily, sometimes not necessary. Some theoretical equations. So they'll ask you in the exam like that. If the displacement is zero, work done is zero. False. Not true. If the force is constant and displacement is zero, then work done is zero. Do you know how does a constant force look like? If I have to give an example, look at this. So if you're going in a circle, and if you're applying a constant force, this is how a constant force looks like. Constant force meaning it will be always looking in the same direction with the same magnitude. This is a constant force. And now how will the displacement look like? This is your displacement. देखा angle change हो रहा है, every instant the angle is different. This is the difference between this and the previous question. In the previous question, see, F and ds were always anti-parallel. Angle was always 180. But here angle is always changing. Here F bar is constant. When you say constant force, the magnitude and direction both should be always same, no matter how you go. Do have a look at this. Please ask me if there's any confusion. There are a lot of theoretical points here. This is arc length. Clear? Any doubts? Anyone not convinced with this? Let's go ahead. Next one. Clear, na? Arnav, Arya, Ritik? Clear? Arush? Perfect. Going ahead. We have a pulley here. We have a block of mass M. We have a block of mass 2m. Initially at rest, or let's say released from rest. Gravity is there. We have two observers. There is an observer A on the ground. There is observer B who's sitting on the block. Observer is just massless, huh? It is just an imaginary quantity. They don't have mass or something. Observer A is on ground. Observer B is on block M. So the question is, find the work done by tension. The strings are applying a force. So find work done by tension on block M and 2M as seen by A and B. These are two different questions and two different blocks. Total 4 answers will come. Matlab, first find the work done on M and 2M as seen by A, then find work done by M and 2M as seen by B in 2 seconds. I hope everyone is getting the question. How much work does the tension do on block M and 2M when A sees it and then B sees it? This is another thing. So if you change the frame, things get messed up. Let's see how will the answers get affected. Anyone didn't get the diagram or the question, please ask. It's your Atwood mission. Hope everyone remembers the standard results. That's what I told you. Work per energy, you will see everything that you learned before will come. Only thing, instead of asking you to draw FBD and forces, I'll ask you work now. Remember, work is simple. Here, tension, displacement. So you know how to find tension, you know how to find displacement in 2 seconds. Try, you got 2 minutes. And then let's see what happens. 2m. Okay. Try. It has a little working. I'll give you 1 more minute. I hope everyone found the tension. Everyone found the acceleration. Then you know how to find displacement. This is the basic stuff. That you must have found it. Now the catch here is that displacements of m and 2m as seen by A and as seen by B are different. They will see different displacements. Let's see. फाइव नहीं आएगा रे, 5 आ रहा है क्या? Let's see. First thing, tension is 2 m1 m2 by m1 plus m2g. Atwood machine should go and revise in case you forgot. This would be 2 to 4 mg by 3. Acceleration would be m2 minus m1 by m1 plus m2g. You could write equations and solve also. That is g by 3. So in the ground frame, the displacement S is equal to half at square. T is 2 seconds. So that is 2g by 3. Now, see what happens. If you ask A to solve the problem, this is what A will say. If you ask A to solve the problem, A will say, okay, this block M is there, tension T is upward, the displacement is also S upward, so work done on M is T into S. Agreed? T ka value no, S ka value hai no. And when you ask him about 2M, he will say, this tension is T, but the displacement will be downward because they will travel opposite directions. 2M will be minus T into S. He will say perfect, meaning everything is great. But now if you ask B, suddenly B will have some different answers. If you ask B, what do you think about M? He will say, this is at rest. Isn't it? So B thinks block is not moving only. B thinks M is at rest because you're standing on it. Therefore, work done on M is 0. Now same thing, if you ask B about 2M, what will it say? Tension T, and it will think it has gone 2S now. Making sense? Technically what is happening, M is going up and 2M is coming down, but this B guy will think I am at rest and this 2M is going double the distance, isn't it? Is that making sense, everyone? Meaning after some time, this is how the diagram would have looked. The 2M would be here, M would be here, this distance was S and this distance was S. But in B ka frame, B thinks that 2M has gone 2S down. So he will say the work done on 2M will be minus T into 2S. So this is an important statement there. Work done depends on the frame of reference. Depending on where you're standing, you can see different amount of works done. So be careful. You will not see the same work in every frame. You can clearly see here, A thinks work is TS and minus TS, but B thinks it is 0 and minus 2 TS. Any doubts on this? Clear? Just stick to the definition. Work done is integral FdS, so that only. So that displacement is as seen by the observer. If the observer himself is moving, displacement does get messed up. So does this create problem with any energy and all? No. We will see later on. It doesn't create any problem. We will show that you have to include pseudo force also. So if you include work done by pseudo force, that balances all the equations. But clear with this? So there. So work done depends on the frame of reference. Let's see one more. Going ahead. Surya, clear? Ahana, got this? Daksha, clear? Jainil, perfect. Next one. We have a pendulum here. This is fixed on the top. This length is L. This is point B, 90 degrees basically. So this pendulum, right, is going from A to B under the action of three forces. Pendulum of length L goes from A to B. Under the action of F1 bar, F2 bar, and F3 bar, three forces. Now, what are these three forces? So first one, F1 bar is always horizontal. Meaning when this guy is going from A to B, this is F1. When it is here, this is F1. When it is here, this is F1. So every instant F1 is acting horizontally. F2 is always tangential. Meaning when you're here, F2 is like this, F2 is like this. So F2 is along the arc. F3 is always directed towards B. Just like that cat and dog problem. Dog is always looking at the cat. So this would be your F3, which is always pointing towards B. So when you're here, F3 is like this. It is always looking at B. Are you getting it? So there are three forces acting on the particle like this. F1 is always horizontal, F2 is always tangential, F3 is always looking at B. Find the work done by F1, F2, F3 when it goes from A to B. Magnitude of forces is constant. All forces have same constant magnitude. Magnitude of forces is constant. Only direction is changing. मतलब mod F1, mod F2, mod F3 are constant. Find work done by the forces when it goes from A to B. I hope the diagram is clear, everyone. So we have a pendulum. It is going from A to B. In this process, there are three forces acting on the pendulum: F1, F2, F3. What is the work done by F1 when you go from A to B? Find the work done by F2 when you go from A to B. Anyone didn't get the diagram or the question, please ask. Question is clear. Go ahead. I'll give you 2-3 minutes. F1 L, F2 pi L by 2. Okay, let's see. Try. Let's see. Now, what I will do, right? Let's manipulate that formula a bit, okay? The work done, if we take small work done, will be F bar dot ds. So this can be written as F ds cos theta. Now, there are two ways you can interpret this. The one which you did in your school level, right, was this. We took F and ds and this cos theta. This is what we did. We resolved the force into components. We resolved this into F cos theta, F sin theta. We can resolve like this. And then you can say the small work done is F cos theta into ds. You can write like this. So then this F cos theta is force in the direction of displacement. So whichever is the displacement, in that direction you take the force. This is one way to take, right? Another way to take this, we have F, we have ds. This is theta. This time divide ds into components. This is ds cos theta and this is ds sin theta. So we are just manipulating that equation there. So dw can be written as F into ds cos theta. So you can say ds cos theta is displacement in the direction of force. Both are right. Now, it just depends on whom are you giving this cos theta to. So you need to see which one is more appropriate. Now, in our case, the second one is more appropriate because I know the force ka direction, isn't it? In my case, second problem, the forces are constant. So this is what I'm going to use. The first one is a standard one, which you must have seen. So now look at our question. This is the pendulum here. So work done by F1. How is F1? F1 is horizontal. So if F1 is horizontal, displacement should be what? Displacement in the direction of force, isn't it? Force is which way? Horizontally. So displacement is which? Horizontal. L. Is that making sense? So work done by F1 is F1 into displacement in the direction of F1. F1 is horizontal, so it is F1 into L. Make sense? So this is F1 into L. Look at the second guy. In this case, if you look at F2, F2 is like this. So here the displacement is this displacement, the arc length, which is pi r by 2 pi r by 4, right? So pi l by 2. The work done by F2 is F2 into pi l by 2, displacement in the direction of force or the distance in the direction of force. Look at the C1. Your force is always looking at B, meaning the displacement is L root 2. The work done by F3 is F3 L root 2. Make sense? You just need to see which way is the force pointing, and in that direction you take the distance or displacement. Clear with this? Quite a useful thing, saves you time. You can actually integrate and do this, but it will be a big mess.
Sir,
You have to integrate.
sir, but the direction of F3 is not constant throughout the journey.
It doesn't matter, na. When you are going from here, see, when you say, let's say like this, you're going like this, and like this. In triangle law, if you add all these vectors, what is the net resultant? Tail to head, right? Now, what you're saying is true. What Puroj is saying, sir, it is not constant, agreed. So it is going like this, right? This vector, this, this. And when you add all this thing, it is this vector only. It won't matter, it will come out to the same thing. Check it out. It's a good question. Easy to solve once you know what you're doing, or else it becomes complex. Check it out. Let's see one more. Any doubts on this? Clear now, Vihan? Yeah. Niharika, got this? Nikhil? Clear? Ansh? Arush? Sharman? Ujas? Next one. We have some weird path like this. This is H and this is L. We have a block M here, and this is a rough surface. Mu is the coefficient of friction. So this block is sliding slowly. So this is the topmost point, and this is the lowermost point. The block slides with negligible speed. Without losing contact from A to B. Find the work done by friction when it reaches the ground. And it reaches B. The second part of the question, what happens if the speed is constant but not negligible? Constant speed of finite value. मतलब negligible नहीं है. Maybe when I say negligible, I'm talking about like 0.00, very slow. But what if you have some finite value? First, let's do the first part and then see the second part. The shape of the curve, I don't know. Okay. Let's see. Now, these kind of questions, how to do? We have seen this is the third time using something like this, some weird path. So consider a small section somewhere here, ds. So I'm exaggerating the figure here, so it looks like this. So theta, remember theta is variable. This is dy, this is dx. Now this looks like a block which is sliding on a small incline. So this will be friction, F max, because it is sliding. This would be N. This would be your mg cos theta. So we get F max is equal to mu into N, which is mu mg cos theta. Since it is going downward, this will be the displacement ds. So the small work done for this small ds will be minus F max ds minus mu mg cos theta into ds. But what is ds cos theta? Cos theta is dx by ds, adjacent side by hypotenuse. This becomes minus mu mg dx. This is the small work done. So the total work done, mu mg is constant, integral dx. This will go from 0 to L because the x coordinate is changing from 0 to L. It doesn't depend on the height, 0 to W. So therefore the work done is minus mu mgl. Independent of the path, it only depends on the horizontal distance. Getting it? And again, valid for negligible velocity. So the second part of the question, what happens if you have speed? What is the problem? If you have some constant speed, maybe 1 meter per second, 2 meter per second, but constant, why is this not valid? Something goes wrong. Can you think? If the block had some speed, how it would have changed? A0, ठीक है ना, यहाँ पे भी A0 ना God. Where is it accelerating here? Negligible speed is almost zero speed. Next thing. What is the catch? Will you be HBL nere? See na, catch was this. When you're going on a circle, see if you're going on a curve, this would be the problem. So at any instant, when you try to do the normal reaction, N mg, now you'll get a centripetal acceleration also, isn't it? Which will be v square by r. So your normal reaction will be, meaning I can take even a centrifugal force. So your normal reaction will be mg cos theta plus mv square by r. You can't write directly mu mg cos theta. That means you'll get an extra term, no, mv square by r. Now problem यहाँ पे क्या था? V I know, but r is variable. R is variable. R is changing every instant. We don't know how to calculate that. So therefore, friction will be mu into N. This is all right, but you can't integrate this. F is mu into N and work done. You will not be able to integrate this. Since R is variable, we don't know how to calculate because it's a random path. Therefore, we cannot calculate. Problem cannot be solved. The only way to eliminate this is what? If you take a negligible speed, this term will become zero, na? mv square by r, the centrifugal force. You can't do anything about r. R depends on the path. The only thing you can do is make the speed zero. If you make the speed zero, then F becomes equal to mu mg and M becomes mg cos theta, and you can solve. We cannot calculate, right? That is the thing. But if V is zero, then we can calculate. You're getting the problem? Meaning, देखो ना यहाँ पे integration में you'll get one more term, mv square by r into ds, right? We can't calculate that, na? I don't know what is r. So therefore, you can't solve this question if it has some negligible, if it has some speed. That speed has to be zero. Please check. Next one. Any doubts on this? It's a good one. Hope everyone is clear why you can't have speed. The centrifugal force. Next one. This is how they'll frame questions. A body moves from point A, which is 1, 1, to point B, which is 2, 3, under the action of force F. So the first question, force F is 2y plus 3j. So constant force. The second question, force is xi cap plus yj cap, meaning force is changing. But different x coordinates and different y coordinates, you have different force. Third, the force is yi cap plus xj cap. Force is, keep your mics on mute, Ray, Sharman. Yeah. Then the force is 2xy cube I cap plus 3x square y square j cap. So there are four different questions. So when you go from A to B under the action of this force, find the work done. When you go from A to B with this force, xi plus yj, find the work done. With this force, find the work done. With this force, find the work done. Four different questions. Find the work done when you go from A to B. These are four different questions. I hope the question is clear. Okay. First one is fine. Get the rest. Okay. Then continue just with the third one. We have two answers. We just got A and B so far. Try. Should I help you with one? I'll show the first one. See, I'll show you a very general method. Listen carefully. So when you say work done, remember work done is F bar dot dr bar, which is a displacement, ds bar, same thing. So r bar vector is xi cap plus yj cap plus zk cap. This is a very general thing, xyz coordinate. So what is dr bar? So dr bar is dxi cap. So r bar is a position vector, dr bar is a small displacement vector. Dyj cap, dzk cap. You're getting it? So if you have a particle at x comma y comma z, this is a position vector and this is a small displacement. So when you have to do the work done, so the force, let's say force also has multiple components, fx I cap, fy j cap, and fz k cap. So if someone asks you to find the work done, this is what you do. F bar dot dr bar, it's a dot product. So this will be integral fx dx plus integral fy dy plus integral fz dz. This is how you find the work done. Fair enough? Now coming back to our question, the force was 2y plus 3j. So applying this formula here, we get work done is integral f bar dot dr bar. This is 2y. I know you can do much faster this thing because f bar is constant. Now you can say force dot product displacement, but then you'll get stuck with BCD. So that's why I'm showing you this general method. This is dx I cap, dy j cap plus dz k cap. So when you do the dot product, you get integral 2 dx plus integral 3dy. Now remember, the x coordinate is you're going from A to B. A is 1 comma 1 and B is 2 comma 3. So you are going from XA, which is 1, you are going to XB, which is 2, you are going from YA, which is 1, to YB, which is 3. So when I integrate this, you get 2, X limits will be 1 to 2 plus 3, Y limits will be 1 to 3. This will be 2 into 2 minus 1 plus 3 into 3 minus 1. That is 2 plus 6, that is 8 joules. There. This is a very general process. Matlab, you can use the same logic for BCD now. Please have a look at the first part. In this case, since f is constant, you can directly say f bar dot s bar. That also would have given you the same answer. That is a catch, Proja. All clear with this thing, first part? There, can you try? C is the catch. C and D are something else. They're little different. C 0. Let's see the B part. A and B part ka same story. Integral is xi cap plus yj cap plus. So the reason I taught you this is, it's the general formula. You can use it for anything. So it always works. Constant variable जो भी है. So this is integral x dx plus integral y dy. This goes from xa to xb, which is 1 to 2. Limits will be same, and this will go from 1 to 3. This is x square by 2. Limits are 1 to 2 plus y square by 2. Limits 1 to 3. This is 4 minus 1 by 2 plus 3 square, 9 minus 1 by 2. That is 11 by 2. Got it? Now look at the third part. Now here the force is yi cap, meaning the force in x-axis is depending on y coordinate. The force on the y-axis is depending on the x coordinate. It's weird. Dot dx I cap, dy j cap plus dz k cap. Story is the same. So when you use the dot product, you get integral y dx. You can't integrate this. Integral x dy, you can't integrate this. But you can do something. If you take them together, y dx plus x dy, this becomes integral d of xy. Product rule. Look at this thing. If I differentiate d of x and y, isn't this y dx plus x dy? Product rule है differentiation का. Is that making sense? You can't differentiate them separately, but together you can do this. Same way, if I take one more example, if you have d of x square y, this is what y d of x square plus x square d of y. So that means this can be written as 2xy plus x square 2xy dx plus x square dy. These kind of functions are called perfect differentials. Quite an important one, huh? These are called perfect differentials, meaning it becomes a perfect thing. So you're treating the whole xy like one new term, isn't it? So what will be the limits? So this will be xa, ya. This is xb, yb. You can't integrate y dx, you can't integrate x dy, but you can integrate them together. Are you getting what is happening? So I'm treating x into y like one single term. So x into ya is 1 into 1, xb into yb is 6. So when you integrate this, you will end up with xy, whose limits are 1 to 6, which is 6 minus 1, which is 5 joules. This is how you solve these kind of things, perfect differentials. It's a good one. Have a look at this. When it goes up vertical, why it will go up vertically? Did you even know how it is going? I simply said you're going from A to B. So did you know even how it is going? It doesn't matter. No matter how it goes, the answer is still valid. The answer which we got is independent of the path. Is this making sense, everyone? This is a technique you use to solve these kind of functions. Vihan, clear, no? Now, using the same logic, if you see D is also a perfect differential, can you do it now? So these two, na, A and D, these are perfect differentials. So keep this in mind, generally. If they say you're going from A to B and you don't tell me how you're going, I can't solve. There is only one way to solve if it is a perfect differential. If it is not a perfect differential, I'll show you one question. Then you have to tell me how you are going. You're getting it? So if you say I'm going from A to B, you have two options. Either it should be a perfect differential or make sure to give me the path. If you don't give me the path, then there is a high chance it's a perfect differential. Have a look at this. Thirty, 108, 19. 107. 107. Okay, we got two 107s. Anyone else? I'll give another 30 seconds. Let's see. So work done is integral 2xy cube 2xy cube. So the main headache is to figure out what will be the differential function I cap plus 3x square y square j cap. So generally, when people see something like this, they'll get like, what the hell? That's what I'm saying. If I don't give you the path, but I just ask you work done, 9, 10 was there's a high chance it's a perfect differential. With that thought in mind, when you solve, right, you won't get tensed. You can, but how do you know it's independent of path? First of, if you can't figure out it's a perfect differential. If you can figure out the perfect differential, why you want to take a path? Right, Vihan? So this would be 2xy cube dx plus 3x square y square dy. So if you try to see carefully, this, can you see this 2x dx? So that looks like x square actually. So when you differentiate x square, you'll get 2x square. So there's a y cube sitting here. Here, can you see 3y square dy? So that is actually y cube ka differential, which is x square. Yeah, so this is d of x square y cube ka differential. Hope everyone figured out that part. So, and what are the limits? So limits will be here, xa square ya cube, which is 1. This is xb square and yb cube. This is 1, 1, 2, 3, na? That is 2 square into 3 cube. 4 into 27, 54, 108. So this guy would be x square y cube. Limits will go from 1 to 108. So basically, I'm treating that entire x square y cube as a new term. That's 108 minus 1, 107. Please check. This is how you do these kind of questions. So you should be able to figure out, okay, this is a perfect differential. It looks like this. Any doubts on this? And remember the term word, perfect differentials. We're going to encounter that few times. This question, right, is quite important. This you'll see again in electrostatics and gravitation. Next one. Now let's say if it is not a perfect differential. F is equal to xy square I cap plus xy j cap. This is not a perfect differential. This is x, this is y, this is 0, 0. This is a, which is a, 0. This is b, which is 0, a. This is c, which is a, a. So you can go like this, and you can go like this. This is path 1. You can go like this. This is path 2, which is y is equal to x square. एक काम करते हैं, I'll give you just coordinates. Wait, let this be 1, 1. This would be 1, 0, and this be 0, 1. And that path is y is equal to x square. This like this. This is path 3. So there are 3 paths you can go. So find work done by the force. The force is constant. You are taking different paths. When it goes along, first thing, OAC, then OC directly parabola. whose equation is y is equal to x square.
Sir, y equals to x square or x?
Then OBC, right? So get them. Clear, Vihan? Yeah. Now this is the difference. See, previous question I gave 4 different forces. Here I'm giving you one force but 3 different paths. If this was a perfect differential, it wouldn't have mattered which path. One path ka answer would have matched with everyone. Let's try this thing. It's a good one. Try. Just give it a try. Back in a minute. Any answers for the first one? Let's start with OAC. Should I show you one? Try. I'll give you a minute, then I'll show you for OAC. We have half, we have 1, we have half, we have 2 halves. Let's see. For the first one, now see, when you're going in paths, right? Don't directly jump into it. Let's go one step at a time. So let's go from O to A first. So ask yourself, when you go from O to A, y coordinate is 0. Agreed? There is no y coordinate. What will happen to your force? Then your force becomes 0 because y coordinate is 0. Therefore, work done from O to A is 0. देखो ना, y is 0, y is 0. There is no force only. That means when you're traveling on the x-axis, there is no force. Now, second part, when you're going from A to C, x coordinate is constant, x is equal to 1. That means your force becomes y square I cap plus y j cap. So only y coordinate is changing. And what about the displacement? The dr bar is dx I cap dy j cap, but dx is 0. This is 0 because x is constant. So this is only dy j cap. That means when you calculate work done from A to C, integral f bar dot dr bar, only the j components matter. That would be integral y dy. Y goes from 0 to 1. This is 1 joule. Therefore, work done to OAC is 1 joule. Check. Ne, y d square by 2 na half joule. This is how you do, everyone. You divide each one into two parts and try to solve. Second one, I don't know the answer, right? But 17 by 32 people got. Any doubts on this? Now, can you do for the path 2? Y is equal to x square. I hope you got the idea now. Y is equal to x square is straightforward. Y का place में x square डाल दो. Try, I'll give you one more minute for the B part. Okay, C is also coming off, yeah? ठीक है. Anyone didn't get this first part OAC, please ask. Which is the second one? So we are going from O to C directly. So force would be y is equal to x square. You can convert everything into x or y. I will convert into x. X into y square will be x power 4 I cap plus, I can convert that also into y. X will be root y j cap. I can do this. I can keep all I caps in x and j caps in y. Then work done will be integral f bar dot dr bar. This will become integral x power 5 dx plus integral y power 3 by 2 dy. Limits will go from 0 to 1, 0 to 1. This is x power 6, so 1 by 6 plus, that is y power 5 by 2, 2 by 5. This would be, how much is this? 5 plus 12, 17 by 30. Check. Next one. What about the other one? OA, OBC. Let's see that. So now we are going OBC. So first let's go from O to B. When you go from O to B, X coordinate is 0, force is 0. The work done from O to B is 0. When you go from B to C, Y coordinate is 1. So dy is 0. Force would be xi cap plus xj cap. And dr bar would be dxi cap plus dyj cap, but dy is 0. So only the dx component would matter. So work done from BC would be integral x dx. Limits will go from 0 to 1. This is also coming out to be half. But this is not a, it depends on path too. Did you see? OBC and OAC become equal. There. Clear with this? You are getting equal because I took 1, 1, na? If I have taken something else, 2, 2, 2, it would have got messed up maybe. Something else would have changed there, but okay. Any doubts on this? So there, you can mess up like this. You can give one path and different forces or like this thing. Any doubts on this? Next one. Next one. So we have a block here. So we have a 10 kg block. This angle is 30 degrees. So there is a rope here. So you are applying a force of F is equal to 10 newtons and pulling the block. Initially the block is here. And when you pull this rope, what will happen? The block will start moving. And the block comes here and hits the wall. This is a smooth floor. Okay. The rope is pulled by 10 newtons as shown. The block slides from A to B and hits the wall. Find the work done by the force. This distance is 10 meter. A to B ka distance is 10 meter. I hope the diagram is clear, right? Because the ground is smooth, it will slide. And if you keep pulling, it will go and hit the wall. $100. First answer आया रे. I know what you did. You took FS cos theta, right? Something like that. Even if you do that cos 30, तो जितना अच्छा नंबर कहाँ से आया? Cos 30 half ले लिया क्या? What did you do then exactly? We have 50 by root 3, 100 by root 3. We have 250 by root 3s. 100 by root 3 looks right. I maybe. Hundred by root 3. 50 by root 3 nahi hai. 50 by root 3 is wrong, gods. For people who used fs cos theta, this is in foundation. People who used fs cos theta, tell me one thing. When the block comes here, is theta constant? Every instant theta is changing. How are you using fs cos theta? Go back to the definition. What is the definition? Work done is what? Force into displacement of the point of application of force. It is not displacement of the block. Are you getting it? It is not the displacement of the block. So when you look at the diagram, initially the block is here. So this was the rope, right? So let's call this point A, and let's call this point C, and let's call this point A. This angle is 30 degrees, and this is 10 meters. So when the rope becomes straight here, this is B, the rope becomes like this. So what is this displacement here? This is your displacement, right? This S is the displacement of point of application of force. You need to take the displacement of the point where you're applying the force. I don't care about the block. Displacement of point of application of force. How much is that? So S will be nothing but AC minus BC. So AC will be cos 30 will be 10 by AC. So AC will be 10 cos 30, so 20 by root 3. Similarly, tan 30 is BC by 10. So BC is 10 by root 3. So this guy is 10 by root 3. Therefore, work done is F into S, 100 by root 3. Clear? Now you can ask, like, sir, can't you do for the block? Yes, you can do for the block, but the problem that is Fs cos theta, theta is variable. I don't know how theta is changing. I don't know how to integrate that. It's not wrong. You don't know how to do it. Check. Unfortunately, that 50 root 3 will be there in the answer. Next one. Next one. This is an FX graph. This is 10 newtons. This is 10 meters. This is 20 meters. Find the position when the work done is 0. Remember, area under FX graph is work done. Root 3, 10 root 3, nay records. 20 plus 10 root 3. That looks right. So basically the total positive area must be equal to the total negative area. So this is how we do. This would be 100. This would be 50. So from here at a distance x, so this coordinate will be 20 plus x. So you need to find 20 plus x. If that is x, remember this is also 45, this is also 45, opposite side and say this is also x. So this area will be half into x square. So total area must be 0. The work done is 150 minus half x square equal to 0. Right? Or yeah, done. So you get, how much is this? X is equal to 10 root 3. You want the coordinate, na? Therefore, I'll do one thing with it. That looks confusing. Let's call this only x comma 0. Then this will be 20 minus x. This will be 20 minus x. And this will be half into 20 minus x whole square is 0. Then we get 20 minus x is equal to 10 root 3. X minus 20. X is greater than 20 now. Easy? There. Just need to find the area and finish it. We did something like this in kinematics, remember? Devansh, what happened? Why are you so happy? Because work done is 0. Nah, you don't want work to be 0. This one, try this as a homework question. Next class, when we catch up, we'll discuss this. Force is given by minus xi cap plus yj cap by x square plus y square whole power 3 by 2. Find work done when a particle goes from 1, 1 to 2, 3. This we will discuss about this. These kind of forces have another name, so we will see that. But you give it a try. You think how you can do about this. You're getting this is minus वो पूरा bracket में xi plus yj denominator is root x square plus y square का 3 by 2. Clear? So do give this a try. So next class when we catch up, we'll continue from here. We will see the paper cut discussion now. So do try this thing. So next class when we catch up, we will do this, and then we will talk about something called conservative forces, and then we'll go ahead with the potential energy, kinetic energy ka definitions. So that will be, we will be doing that, and then after that we will go for work energy theorem. So step by step. First, what is work, and then relation, what are energies, and then the relation between them. So first, any doubts in today's class notes? Anything you can ask me?